So I want to spend a couple of minutes talking with you about the Kentucky Science Assessment System. What are some things that we can expect? What are some of the nuts and bolts of things that we need to know? And really, what is this process and how do we get started with it? So I want to start off with talking just a little bit about some of the shifts from the way that we have been assessing scientific understanding and the shifts in the new assessment system. So the old system that we've been spending the last several years really assessing scientific understanding was really revolved around just that scientific understanding. We really weren't getting through the assessments. We really weren't assessing a student's level of scientific application. We were getting to their understanding of scientific concepts, but we weren't really getting to this idea of how are we applying our understandings to explain the world around us. We really weren't able to see, based on the state assessment, we really weren't able to see how kids were applying their scientific understandings. If we had a classroom that was really aligned, that allowed kids to demonstrate that, that was one thing. But our Kentucky assessment system before really didn't give us the opportunity to see that. And so the changes that they've made through really spending some time understanding the 3 dimensions of the Next Generation Science Standard has really allowed us to think about how do we make shifts in our assessment that is going to really reflect the shifts in our instruction. In our classrooms, we really want to know, how do kids apply these scientific understandings to explain the world around them? And so a lot of the times our assessments will really kind of make an impact on the way our instruction looks. And so when we have an assessment that's just designed around scientific understanding or ideas, that really kind of impacts the way that we instruct students. Our instruction is focused more around the scientific knowledge and ideas. When we have an assessment system that really asks kids to apply it and to think about the world around them through a scientific context, then that really adjusts the way that we instruct them as well. And so I think something that's nice is that they have revamped our science assessment system to align with what we know is good teaching for science instruction. We know that science instruction isn't just about, I hope you have a list of these vocabulary understandings, these are important words for you to know, or these are just some basic science facts. We know through teaching science that's important for kids to apply it and for them to think about the world around them. And so it's nice to see that they have started to make shifts in the assessment system that really reflects how we teach science and what we know is good science instruction. And so that's really kind of the big shift between the old and the new. So I want to talk with you just a little bit around, there's 3 different levels, and the purposes behind this level of assessment is pretty different than what we've experienced in the past. So with the core content assessment, most of our formative assessment work was really designed to help us predict what level of proficiency our kids were going to be able to achieve on the end of the year summative assessment, our state assessment. So most of our work with our assessments was all predictor. It was just to make a prediction of their achievement. So the new science assessment system that we are going to be utilizing is not to be used as a predictor. So the shift is that this is really around our day-to-day instructional decisions for our kiddos. We really want to look at this as a system of good teaching and learning. It's around teaching scientific understandings and practices and thinking like a scientist in application. And then assessing the work that the students are doing and helping us to really look at our effectiveness in relation to that idea and make some good next step decisions. And so most of our assessment system that we're going to be talking about is really formative work that we do already with our teaching and learning a curriculum and instruction that we have now. And so I think that this is going to be more aligned with the way we really teach and do business. So we have a classroom embedded assessment, a through course task, and a state summative assessment. And so the through course task is something that we're going to spend most of our time on during the learning workshop, and I'll give you some more examples and opportunities to kind of think through some of these things. But basically, the first 2 levels, classroom embedded assessment and the through course task, is really to inform us about kids' understanding and to inform our instruction. And it also gives us an opportunity to calibrate our understanding of students, the success criteria that we're setting for students in relation to these standards. So it's very collaborative. This whole system isn't a standardized test that you just give kids and then the information doesn't really impact our instruction. The way that they really wanted to make a shift in our assessment system in relation to science is meant to really impact our day-to-day instruction with kiddos, and for us to really have a great opportunity to work with other teachers and develop an understanding of what is the level of understanding that we are really expecting for our kids to have in these particular learning tasks. So basically, they're very formative and they're a part of the day-to-day instructional decision making. The state summative assessment is still going to occur at the end of 4th grade, 7th grade, and 11th grade. And they're designed in a way that they really are assessing the 3 dimensions of the Next Generation Science Standards. And when I say 3 dimensions, I'm talking about the science and engineering practices. And those include asking questions and defining problems, developing and using models, planning and carrying out investigations, analyzing and interpreting data, using mathematics and computational thinking, constructing explanations and designing solutions, engaging in argument from evidence, and obtaining, evaluating, and communicating information. Those are the 8 science and engineering practices that we see in all of our performance expectations in science. Another dimension that we have within our standards is also the disciplinary core ideas, and that's what we normally think of as science understandings. That's our content. So that's like your life sciences and your earth sciences and the different domains in science, physical science. When we're talking about different concepts of science, those are your disciplinary core ideas, and that's the 2nd dimension. The 3rd dimension is your cross-cutting concepts, and that's really these particular ideas that carry across all domains of science. So, for example, one cross-cutting concept is energy and matter. You don't just experience energy and matter in one domain. Energy and matter impact every domain of science, and so that's a cross-cutting concept. So as kids develop an understanding of energy, they begin to see how it impacts all these different phenomenons and things that happen in the world around us, and how energy really plays a part in that. Another cross-cutting concept is patterns. There's not a pattern that exists just in one domain. Patterns are a part of every domain of science. And the same thing with systems and system models. Those exist across all domains. And so the cross-cutting concepts are really that 3rd dimension that really looks at what is an idea or an understanding or a big picture view that I need to be thinking about across all domains of science. And so those are the 3 domains: science and engineering practices, disciplinary core ideas, and cross-cutting concept. The state summative assessment assesses all 3 of those dimensions in one assessment, once end of the year state assessment. Now it looks different, and there's a couple of different components to it, but their goal is to really assess all 3 dimensions. The through course tasks really spends time assessing not as much the disciplinary core ideas or the content piece. It's really focused in on assessing the science and engineering practices and the cross-cutting concepts. So it's going to spend time thinking about how are kids able to really look at a particular phenomenon and notice and ask questions. How can they develop models for this? How can they really plan an investigation? How can they interpret data or really construct arguments and explanations from whatever this phenomenon is, based on their understanding of it from a scientific perspective. These through course tasks are also going to be thinking about what are some patterns that exist, maybe in one domain of science that could help me explain this one. What does energy have to do with this particular phenomenon? So it's going to give kids an opportunity to think about those cross-cutting concepts that they've been learning about and the science and engineering practices to really fully explain this particular phenomenon that's occurring. The classroom, so it's really a 2-dimensional. It's really focused on 2-dimensional assessment. they do talk about the disciplinary core ideas, but it's not a prerequisite and able to access the tasks. If there is a piece of disciplinary core ideas within this task, there will be. Those are anchors to give the kids something to think about. But the information around that disciplinary core idea will be embedded into the through course task. So if they come without a particular knowledge base around, I don't know, a life cycle, then that's okay, because the through course task is going to give us information to really help them access it. And then they'll be thinking through the other two dimensions. Classroom embedded assessment can be 1, 2, or 3 dimensions. It's important for us to also look at disciplinary core ideas and what are student scientific understandings. So it's okay if some of our classroom embedded assessments are focused in on one of the dimensions. Maybe we do need to know what do they understand around internal and external structures of plants and animals. It's also important for us to think about the science and engineering practices. Maybe it's important for us to think about, in relation to this particular phenomenon, can they plan an investigation to answer their questions? We could also be thinking about how are they using patterns to help them make sense of this particular phenomenon. So each level really helps us to think about three-dimensional assessment, but also helps us to be mindful of how are we planning three-dimensional learning opportunities for these kiddos. And so when I talk about phenomenon, let me kind of break down what I mean by that. A phenomenon is an observable event that students can use the 3 dimensions to explain or make sense of. So it's kind of like their anchor. It gives them something to talk about, something to think through, something to reason through. So it's something in the world around us that they can reason through scientifically. A phenomenon does not have to be something phenomenal. It's just an observable event that can be explained scientifically. Most everything that's occurring around us can be explained scientifically. Focusing on a phenomenon encourages the bundling of the performance expectations across different domains. So what I mean by that is, like we talked about a domain of life science, that might have a really great connection to something with physical science. So when we look at a phenomenon and we're trying to explain something that's happening in the world around us, we don't want to just stick with, oh, this is only around life science. But it's important for us to really think about what are some other areas or domains of science that would really help us to create a well-rounded explanation of what's occurring in this particular circumstance. So it really encourages integration of other scientific ideas instead of just trapping us in a silo of understanding in science. So it helps us to be flexible between different domains. Here's just a couple examples of some phenomenon. Sunburn, disappearing beaches, camouflage. These are just some simple things that happen in the world around us, that they have a scientific explanation exists for why these things occur. In our next video, I'm going to talk with you a little bit more about each of the different assessments that are within the system. And give you a little bit more detail about it. So I hope that this overview kind of helped to explain a little bit more around what the shifts are in our old assessment system compared with our new science assessment system, the why behind it, and hopefully how this assessment system is going to align much more with what we know is best practice for teaching and learning, instead of using all assessment as a predictor, but really using our assessments as a next step decision process for teachers, and how do we take our students to the next level. So thank you, and I hope that clarifies some things. If there's any questions that you have, I'm going to give you an opportunity to jot your questions down in one of the discussion threads. So thank you.